Now we'll try to see various kind of questions which are related to the hashing concept, right? So these are some of the questions which was asked earlier. So a hash table contains 10 buckets and uses linear probing to resolve the collisions. Means what? They are using a kind of a hash table where this hash table contains 10 buckets. 10 buckets. If I am saying that there are going to be 10 buckets, what will be their indexes? It depends on again the hash key, right? You have to consider that key modulus 10. So it is always going to range from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The key values are integers and the hash function used is key modulus 10. If the values are 43, 165, 62, 123, 142 are inserted in the table, in what location would the key value 142 be inserted? Right? What you can do? So initially we'll get the 43. 43. What is 43 modulus 10? 3. So 43 is going to be stored at third index location, right? Majority of you know already, but some people might not know. So I am trying to explain once again. Next, we'll take 165 modulus 10. You are going to get the remainder as 5. So at the fifth index position, I will try to save 165. Next, 62. 62 modulus 10. You are going to get the 2. So at the second index position, you are going to get 62. Next, 123. 123 modulus 10. You are going to get the 3 index position, right? But if you look into the 3 index position, there is already a data is there, right? So when there is already data, so they are using the technique called linear probing. So in linear probing, what will happen? We are going to simply add plus 1 modulus 10. So you will get fourth position. So here you are going to get 123. 123. Next the value is 142. 142. If you try to find out 142 modulus 10, you are going to get the value 2, right? So if you go for the second index location, it is already filled. Linear probing with value 1 filled, 2 filled, 3 filled, 4. With the linear probing 4, you can able to place the value 142, right? In what location the key value 142 be inserted? Which is the location? 6th. So the answer will be option D. Okay, fine. Next one. Consider a double hashing scheme in which primary hash function is h1 of k equal to k mod 23 and the secondary hash function h2 of k equal to 1 plus k mod 19. Assume that the table size is 23. Table size is 23. Then the address returned by the probe 1 in the probe sequence, for key value k equal to 90 is. Right? How we are going to solve it? If you are going to observe, what is the meaning of double hashing? Right? So basically in open addressing, we are going to have three types of techniques, right? One is linear probing, quadratic probing and double hashing, right? So to overcome the drawback of primary clustering and secondary clustering, we are going for double hashing. In double hashing, we are going to use two functions. So if I say h of k comma I, right? If I say h dash of k comma I, that will be h1 of k plus I into h2 of k mod m. M is the size of the table, right? So try to substitute. So probe 0 means what? For I equal to 0, right? Probe 1 means what? I equal to 1, right? Meaning that they are simply asking for h1 of k means what here? 90 comma 1 equal to, what is h1 of k? They have given the formula k mod 23. What is k here? 90 mod 23 plus probe is 1, h2 of k 1 plus 90 mod 19 whole mod 23. What is the value you are going to get? Calculate it. If you are able to calculate it, your answer will be 30 number. Your answer will be 30. So the given for the given question, the correct answer will be 13. You can just calculate it. Okay. Take out the next one. Given the following input, something like this they have given, and the hash function is x mod 10. Which of the following statements are true? 9679, 1989, 4199 has to the same value. What is the meaning of it? Is they are going to point it to same value? Yes or no? Yes. So simply it is going to be mod 10. Mod 10 means what? Here it is going to get the index location 9, 9, 9. So has to the same value means option 1 is perfectly correct. What about option 2? Option 2 is also correct. Modulus 10 is what? 1, and the second one is also 1, has to the same value. Good. Is all elements has to the same value? No. If you are able to observe, this will end with 4, end with 1. Here itself I can say that they are not going to say hash with the same value. Am I right? Yes. What about the next one? Is each element hashes to the different value? No again. If you look into the examples of these two, which is going to end with 9, which is also going to end with 9, this itself says that it is going to be an incorrect one. So option 1 and 2 are going to be true, right? So here they are not specifically thinking about like chaining or open addressing. They are simply saying that hash to the same value or not. Like so indirectly they are saying that you need to find out the index portion. So for the given question you need to worry about like what kind of technique they are following. Try to take out the next one. The advantage of chained hash table, we can call it as external hashing, over the open addressing scheme is the first one is true. Worst case time complexity is less or more? More, right? If you try to take any kind of a hash table, for example, if I am going to have 10 keys, all those 10 keys may be led to a long chain of size 10. So at the worst case it will be the lengthy one. It is not going to take the less time complexity. So option A is wrong. Is space is less? Directly no. Because it is, we are using in chained hash table, we are using external tables, external data, right? So space is definitely not the less one. And what about the deletion is easier? Yes, this will be the better one. Because if you are going to use something like this, 6, so I think ending with 6 only. Am I right? Ending with 6, they are going to point it like this, right? If I try to find out the search value is 56, we find, and if you would like to delete this one, what I can do? I can just simply swap this addresses, right? This address I can write here, sorry, this address I have to write here, and this address I have to write here, right? If I write that much easier, so deletion is easier here. So next one, try to solve this question. Which one of the following hash functions on integers will distribute the keys most uniformly over 10 buckets numbered from 0 to 9 for I ranging from 0 to 2020? Means they have given simply a hash table. This hash table having 10 buckets, 10 buckets ranging from 0 to 9, and they are going to have the keys from 0 to 2020. 0 to 2020. Which of the hash function will lead to distribute these keys uniformly over all kind of indexes, right? So probable on an average, for every index you are going to get 220 values. Am I right? So 2020 values means on 10 buckets 220 values you are going to get probable, right? So which kind of hash function is the best one among the given that will lead to uniform distribution? Think about it. You can take some pen and paper and try to do work out on it so that you will get the clear idea. Hmm? So guys, here you may just think about like, if I am going to have the key, if I am going to have the key, something like any kind of a key. I means what here key, right? So if I try to perform square, what will happen? It will end up with what values? Always those values only, right? Right? 1, 4, 9, 5. Another 3 or 7 anyway might not be get. Anyway they won't get, right? So if they are not getting 5 or 7, sorry 3 or 7, what are the meaning of this one? At the 3 index location or the 7 index location, 0 cases, right? Which means I can directly eliminate this one, right? What might be another cases? Right? So if you are going to clearly observe, this particular thing also going to be invalid. Why? Right? If you try to perform I square into 11, what will happen? Again you are going to get the same data only, right? So means again you are going to avoid 3 and 7. We are going to avoid the 3 and 7. So option C can be eliminated, right? What about option D? So if you are going to take the 12 into something, the last number is a kind of what? 2. 2 is going to multiply with anything, you are going to get always even numbers. Always going to get even numbers, right? So even numbers means what about the odd case indexes? They are unevenly distributed. So option D is also going to be eliminated. Then the remaining option is option B. But if you look into carefully about the power of cube, anything value over cube, it's always going to produce all the values from 0 to 9. If you want, you can just cross check 0 to 9. The only number which is going to get always all the values is cube value. I mean cube or power 9 or 27, like that, right? Powers of 3, right? So the option here is option B, right? So try to do it the another one. A hash table with 10 buckets with 10 buckets with 1 slot per bucket is shown in the following figure. The symbols S1 to S7 initially entered using a hashing function with linear probing. The maximum number of comparisons needed in searching an item that is not present is. What they are asking, when I am trying to searching something, at the worst case, how many number of comparisons is going to be done, right? So while trying to perform insertion, they are using what kind of technique? Linear probing, right? So when they are trying to insert the linear probing, they have inserted. So if I would like to search certain item, for example, let me call the certain item is, by using certain kind of hashing function, I have applied the algorithm what they have used, S8, which will be indexed to 3. If it is going to be indexed to 3, where it is going to be inserted? At the here. Inserted, right? Yes. This is okay. Now, this is the way they have inserted, right? So, if something is going to be happen to search, what might be the maximum number of comparisons? So, for example, if any particular value is going to consider the block from 8, if I say something like S9 indexes is going to be at 8, then it will search for S6. Is S6 equal to S9? No. S3 equal to S9? No. Then S7 equal to S9? No. S1 equal to S9? No. Then how many comparisons is done? 4. Will it is going to be stop? No. It is going to search for what? Next also, right? It is going to search for next block is free or not. How can it stop the process? By occurring an empty block, right? So how many comparisons is done here? 5 comparisons. So answer will be 5 here. It means simply we can call it as size of the largest cluster plus 1 in searching. Right. Next one, try to do this. A hash table of length 10 uses open addressing with hash functions h of k equal to k mod 10 and the linear probing. After inserting 6 values into the empty hash table, the table is shown as below. This is what they are getting. How many different insertion sequences of the key values using the same hash function and the linear probing will result in the hash table shown above. What they are asking simply, they have used certain set of keys in certain order. They got the table like this. Is it okay, everyone? They got the table like this. Now, if the actual taken data, if I am going to arrange in certain order, again they will be come again in this order only. What are those, or how many ways it can be possible? That is what they are asking. So let me give some simple example. For example, they have mentioned something like 46, 42, 34, 52, 23, 33. Option A. Option B is 34, 42, 23, 52, 33, 46. Option C, 46, 34, 42, 23, 52, 33. Option D, 42, 46, 33, 23, 34, 52. Which of these options will lead to this particular table if they are using k modulus 10 as a hash function? Option C is the correct, no need to explain, right? So by simply applying mod 10 operation, you are going to get this particular thing, right? So actually this is for 1 mark and this is for 2 marks. Totally they have given for 3 marks. This is a gate question, right? And later the second continuous question is this one, what I have asked. So this is might be the correct answer, right? This will be the correct answer. Now they can able to arrange this particular input in various kind of different ways. In various kind of different ways. Again they may lead to again the same table. What are those many ways? That is what they are asking. So how can we do it, ma? Try to check. I will do so that you can understood. Try to observe. If I say the data will be like this: 46, 34, 42, 23, 52 and 53. 53, right? For example, if I change my 33 order to here, my 33 order to first one, his output is going to be changed or not? Yes. So I should not change 33. Can I change the output to here, 33 to here? If I change 33 to before 52, what will happen? Is it same? No. It is going to be filled at this particular block, right? So 33 I should not change at least one position also. Finally I can say that 33 should be the definitely at the last position. Definitely the last position, right? Suppose if can I change the 52 to any position? If I change 52 to here, any problem? There will be a problem because this particular block is going to be filled. So definitely I can take this 52 before 42. If I take the 52 before 42, what will happen? Again there will be the problem. I should not take. Can I take after 42? If I take after 42 also, again there will be a problem because 23 place is going to fill with 52. So I should not change this particular position also, right? So now take out these 4 values. Can I change these orders? Can I change these orders? 2 followed by 42, 323, 434, 646, right? If I change the orders, is there any problem? No. So in how many ways I can change these orders? 4 factorial ways. So total 24 ways I can get here, right? Is there another particular solution? Is there alternative way? 46. Try to think. 46, 34. If you are able to clearly observe, guys, here you can observe one thing. I made these 3 are fixed, right? They will come in any order. These 3 are something like 3 factorial. Now after this, I mean 46, 34, 23, they can come in any order. And what about 46? Sorry, it should be 42. Can I change like 52, 46 and 33? Is there any problem? There is no problem, right? So again this is a kind of a combination again. 52, 46 and 33, right? So now how many ways they are going to arrange? 6 ways. 6 ways. Like this, is there any other things are possible? So there are no other possibilities are there if you check, right? So total is how many ways? 30 ways. Okay. Try to solve this one. I think this one was covered in the class itself. What is load factor? Load factor means the total number of elements which are occupied for each and every bucket, right? I mentioned, right? I have solved one particular problem. This is 0, this will be something like 3, 1, so and so. 0 plus 3 plus 1 plus and so on by total size of the table, which is 1. This is what we called as load factor, right? So here, given a hash table T with 25 slots that store 2000 elements. What will be the load factor for T? Which will be simply 2000 by 25, which is something like 80. How they distributed its load, right? So you can just cross check the earlier class notes so that you can get the idea. Try to solve this one. Consider a hash table of size 11 that uses open addressing with linear probing. H of k equal to k mod 11 be the hash function used. A sequence of recorded with keys 43, 36, 92, 87, 11, 4, 71, 13 and 14 inserted in the initial empty hash table, the bins of which are indexed from 0 to 10, right? Modulus 11 means what? 0 to 10. What is the index of the bin into which the last record is inserted? Solve it. Tell me what will be the answer? So I think this will be the easy one. You can solve by yourself. So 7 will be the index portion where your data is going to be inserted. Have you got it? Yes, sir. Good. Next one. Consider a hash table of size 7 with starting index is 0 and a hash function 3x plus 4 mod 7. Assuming the hash table is initially empty, which are the following is the contents of the table when the sequence 1, 3, 8, 10 is inserted into the table using closed hashing. Note that underscore denotes an empty location in the table, right? So means they have clearly mentioned a table of size 7, 0, 1, 2, 3, 4, 5, 6 and 7, right? So here they are using the hash function as 3x plus 4 mod 7, right? So 3x plus 4 mod 7. If you got the values as 1, 3, 8, 10. 1, 3, 8, 10. So what will be the location it is going to be inserted? So which will be x value as 1, 3 plus 4 is 7, 7 modulus 7 is 0. So at the 0th location it will be the 1. What will be the 3? 3 3s are 9, 9 plus 4, 13, 13 modulus 7 is 6, right? At the 6th index location you are going to have 3. 8 means what? 3 8s are 24, 24 plus 4 is 28, 28 plus 28 modulus 7. 7 4 is 28 which is 0. So you are going to get here as 8, right? 8 and then you are going to get the value as 10, 10 3 is 30, 30 plus 4 is 34, 34 modulus 7 is again 6. Here there will be no 7, okay. If there is no 7, then it will be 30 plus 4 is 34 modulus 7, again 6, right? So I think they are using here closed hashing, right? They haven't mentioned anything, so you can just directly go for linear probing, or you have to go with the options again, right? So if you go with the linear probing, your 10 might be inserted here, right? 6 collision, 1 collision, 8 collision, 10 inserted here, right? If you look into the answers, it will be matched with 1, 8, 10, 3 blanks followed by 3. So option B is the correct answer, right? Hope you understood clearly, right? Okay, we can stop here. With this, we complete the syllabus also, both lab as well as theory. Not